Alright, here we go, factoring part 2. We're first going to look at some problems that are specifically difference of two squares, or working off that notes page. It's these problems right here. Now, in a difference of two squares, it's a special case, and it comes from, say, if we were to multiply x plus 6 and x minus 6. And when you and I notice you have the same number here, but one's plus and one's minus. So if I do my double distributing, I get x squared minus 6x plus 6x minus 36, and the 6x's in the middle cancel out, and you end up with x squared minus 36. And this only happens when one is plus and one is minus. If you tried x plus 6 times x plus 6, you end up with x squared plus 12x plus 36. And if these were both minus, it would be x squared minus 12x plus 36. But when one's plus and one's minus, those outers and inners terms cancel out, and you're just left with this. So if I had to factor x squared minus, this problem right here, minus 36, special case because the square root of x squared is x, the square root of 36 is 6, and there's a minus between them, which means it's a difference of two squares, so it must be x plus 6 and x minus 6. Number 2, I'm just going to rifle off some really fast examples here. X squared minus 25. Square root of x squared is x. Square root of 25 is 5. There's a minus between them, so it's that special case scenario. And it's x plus 5, x minus 5. Number 3. Negative 2x cubed plus 50x. Huh? This doesn't look like number 1 or 2. But we have to remember the first step of factoring. The first step of factoring is always factoring out common factors. What do these two things have in common? They're both even, so I'm going to factor out a 2. They both have an x, so I'm going to factor out an x. And then also, because I don't like this first term being negative, so I'm going to factor out a negative 2x. And if I do that, what's left on the inside is x squared minus 25. And if you forget how to do that, just think divide. Negative 2x cubed divided by negative 2x is x squared. Or 50x divided by negative 2x is equal to negative 25. And now x squared minus 25, that looks a lot like what we saw in number 2, yeah? So you can now factor this thing, the second step of factoring, and it becomes x plus 5x minus 5. Wow, multi-step factoring problem. All right, example number 4. 3m squared minus 48. Hey, these have a common factor. 3 and 48, they're both divisible by 3. So if I can factor out a 3, what would be left on the inside is m squared minus 16. And now this is a difference of two squares. Square root of m squared is m. Square root of 16 is 4. There's a minus between them, so this is the shortcut of m plus 4, m minus 4. Two more of this variety. Number 5. 4w squared minus 9. Now in those last couple problems, I factored out common factors. But do these problems have a common factor? Nope, 4 and 9 have nothing in common. So, but I do know the square root of 4w squared is 2w. Square root of 9 is 3. There's a minus between them, so it's a difference of two squares. 2w plus 3, 2w minus 3. Finally, number 6. X squared plus 36. People love to answer this one, but it's wrong. They love to answer x plus 6 times x plus 6, or x plus 6 squared. But let me go up to the top up here and remind you of something. When you go x plus 6 times x plus 6, you get x squared plus 6x plus 6x plus 36. So you get x squared plus 12x plus 36. This thing down here is missing the 12x to let that x plus 6 quantity squared work, which means it's not a difference of two squares, so we can't do the plus minus thing. This one is not factorable. There's no common factors. It's not a difference of two squares, so this one would simply be not factorable. All right, the last one. Last thing I need to show you, and this is the factoring that people find most difficult, and this is the trinomial, specifically when a is not equal to 1. So for example, number 1, let's say I had 6x squared minus 13x minus 5. Now, in your algebra class, you probably learned some shortcuts a couple years ago. And in all honesty, if you remember how to do that trick, it's a good trick, and you should continue to use it, and you should use it all year. But if you learned a trick on how to factor a couple years ago, and you do not remember that technique, it wasn't a good technique, because you don't remember how to do it. In fact, I have a technique for factoring these type of problems, which I think is boss and is super duper good. But I've also learned that even though my students like it, the next year most kids don't remember how to use it. So even though I really like my own shortcut, it's not a good shortcut for others necessarily, because they don't remember how to use it. So if you're going to use a shortcut on factoring, make sure you remember how to use it next year. Make sure you learn from it. The technique I'm going to show you right now is not a shortcut. This is the roll up the old sleeves and just get to work. Now, this is the opposite of foiling, the opposite of multiplying, the opposite of distributing. So at the end of the day, I need the front two terms. It needs to multiply to 6x squared. So it could be x and it could be 6x, or it could be 2x and it could be 3x. To multiply to a negative 5, it could be 1 and a negative 5. Or it could be a negative 5 and a 1, but I'm not going to worry about the negative thing because we've talked about this, and it'll show up in my work. In fact, it will. Instead of using positive 1, negative 5, I'm going to use no. Why not? Why not positive 1, negative 5? Okay, so maybe x and 6x lines up with 1 and negative 5. So maybe it would be x plus 1 and 6x minus 5. Or maybe it'd be the other way around. So it would be x minus 5 and 6x plus 1. Those are the two ways that x and 6x could match up with 1 and negative 5. Next, the 2x and the 3x. So 2x plus 1 and 3x minus 5, or the 1 and the negative 5 could be the other way around. And it could be 3x minus 5 and 2x plus 1. These are kind of the 4 different possibilities. It could also be, instead of like positive 1 and negative 5, the negatives could be switched, but we'll figure that out as we're doing this next thing. Now, in all of these ways, the first two terms, these two terms multiply to 6x squared. These terms multiply to negative 5. So what we need to do is we need to test out the outers and the inners to see what adds up to negative 13. So negative 5x plus 6x is 1x. That ain't it. Positive x minus 30x, that's negative 29x. That ain't it. Negative 10 Wait a minute. Has Elliot made a mistake here? Something ain't right. I'm not sure yet. I'm going to have to think about this. Negative 10 and positive, so I have negative 10x plus 3x is negative 7x. And then finally, positive 3x. Oh, I see what I did. On this one, I switched the x and the 2. Essentially, this one and this one were exactly the same. That's silly. I need to keep the 2x in front, so it's 2x minus 5 and 3x plus 1. Okay. Sorry about that. So when I test out this one, I get 2x minus 15x, which is that negative 13x that I'm looking for. It's always the last one you try, isn't it? So because this is the way that the outers and the inners multiplied, this is my answer. And that's how you're going to go about factoring 6x squared minus 13x minus 5. So students, I'm running out of time right now because I have a fourth period needs to come in and take the test right now. So they're going to do that. And I do have 2 more examples I want to show, but I'm going to make this video later on today and I'll put it up. So maybe if in all honesty, if you were able to if you factor this and you're like, I get this, then go ahead and start practicing. But if you want to practice a couple more problems with Elliot, then you're going to want to watch the next part of this lesson. I'll talk to you in a couple of minutes. Bye-bye.